Which of the following physical quantities is not a vector? Well, if it is not a vector, then what is it? It is a scalar, a physical quantity that has only magnitude and no direction. Let's look at our options. 1.1, we have distance. We know fully well that distance is a scalar. So the answer to 1.1 is A, because distance is not a vector, it is a scalar. Force is a vector, velocity is a vector, and acceleration is a vector. Let's look at 1.2. In the equation, Vx is equals to Vi delta t plus a half A delta t squared. Vi delta t represents what? Let's look at Vi delta t and make sense of it. Vi, that is the velocity. So we have velocity, and then delta t is the time, obviously. So we have velocity multiplied by time. Velocity multiplied by time gives you what? It gives you displacement. Velocity multiplied by time, it gives you displacement. So the answer to 1.2 is D. The answer to 1.2 is D, because Vi multiplied by delta t will give you the displacement. Let's look at 1.3. Which of the following is obtained by calculating gradient of displacement versus time graph? Displacement versus time graph. Displacement versus time graph. If you calculate the gradient of displacement versus time, you will get velocity. And if you calculate the gradient of velocity versus time, then you will get acceleration. So the answer to 1.3 is velocity, which is B, which is option B. The gradient of displacement versus time is velocity. If the question was saying velocity versus time, the gradient would give us the acceleration. Let's look at 1.4. In 1.4, in the diagram below, a pendulum bob of mass m is released from point A and swings past points B, C, and D. Ignore all effects of air resistance. In which of the following position will the value of the gravitational potential energy of the pendulum bob be the smallest? So what is gravitational potential energy? It is the mass multiplied by the gravity multiplied by the height. The mass is gonna remain the same, obviously. Gravity is gonna remain the same. So we're interested on the height. The smallest height will give you the smallest gravitational potential energy. So let's go and find out at which point is our height the smallest. A seems like it's our highest point, and then B and also D. As you can see here, the smallest height is at point C. At point C, that's where we have the smallest height. So the answer here would be option C, because that's where we have C, right? The gravitational potential energy is the smallest where the kinetic energy is the highest, and that is at point C. Let's look at 1.5. 1.5, the number of sound vibrations per second. That is the frequency. So the answer to 1.5 is actually B, because we know that frequency is equals to 1 divided by the period. The number of vibrations per second, the number of wavelength that passes a point in a second. Option B, the frequency. Let's look at 1.6. So in 1.6, we have two identical spheres, A and B, on insulated stands that carry different charges. The spheres are brought into contact and separated again. If the charge on sphere A after the separation is Q, the charge on sphere B after the separation is. So if you bring two spheres into contact and you separate them, the new charge is going to be Q new, that is equals to Q1 plus Q2 divided by 2. So you can see from this formula that the charges on the two spheres after bringing them into contact and separating them should be the same. So if we're saying that the charge on sphere A is Q, then the charge on sphere B after separation should also be Q. So the answer to 1.6 is B. 1.7, we have a circuit diagram given to us. The question is saying, what is the voltage across the parallel resistors? So our battery, our total voltage is 7 volts. And then we have a resistor here that is dissipating 4 volts, another resistor with 1 volt. So we know fully well that, so let's say 1.7, we know fully well that VT, the total voltage, is equals to V1 plus V2 plus V3 and so on. V1, V2, V3 being all places where voltage is dissipated. We're looking for the voltage across the parallel resistors. We're looking for the voltage across the parallel resistors. So VT, the total voltage is 7 volts. And then here we have 4 volts being dissipated. So we're going to have 4 plus 1 and then plus the voltage in parallel. So this will be 7 equals to 5 plus Vp. If you take 5 to the left hand side, you're going to get 2V being equals to the voltage in parallel. That is option C. So the answer to 1.7 is C. 1.8. Which of the following statements best describes resistance in parallel? Let's read and see what makes sense. Option A, adding more resistors in parallel decreases the total current of the circuit. That is not true. And then option B, adding more resistors in parallel decreases the effective resistance of the circuit. We know that to be true, so the answer to 1.8 is actually B.